kind of go through some questions from your stats old tests, so that way you kind of have a way to review some of this material, okay? Feel free to pause this video and try it at your own pace to see what you can do without my help. All right, so a survey was conducted at the ages of teachers at a large high school. Here is the data. So I have a stem and leaf plot. Remember, this number here is saying like 22, 30, 35, so on and so forth. And I want a box plot. Remember, when you're looking at a box plot, this number is your minimum value. This is your Q1, your Q2 or your median, your Q3, and your max value. So when I'm looking at this, I'm going to try and eliminate as many answers as I can. I can see these are already in order. My lowest value is 22. So A could be at 22. B is definitely not at 22, so B isn't wrong. C could be at 22, and D could be at 22. So I've eliminated at least one answer. I know my highest answer is 67. So A could be at 67. I've already taken away B. C is definitely not at 67. It's not C. And D is at 67. So the first thing I'm going to do is find my Q2, which is just half of the data. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's do 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 1, 2. So we have something like 36. So A is at 36. D is clearly not at 36 in that middle term. So I already know my answer. I don't have to do any more work. Now, if you do want to remember how to find Q1, remember you take the top half of the data. So you would do, cross off 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, so on until you find that number in the middle of the top half of the data. Q3 is in the bottom half of that data, okay? And again, that's how we find a box plot. All right, Mrs. G took her daughter Susie to the pediatrician for her one-year checkup. The doctor reported that she was in the 95th percentile for her height. Which of the following is a correct interpretation of this? Susie's height is 95% above the height of mean of babies. Percentiles has nothing to do with mean, so if it's talking about the mean, we know that's incorrect. So we know A and B are incorrect. Susie's height is less than 95% of all babies. False. Percentile is always who you're above. So Susie's height is more than 95% of all babies' heights. Okay. The following two histograms show fat content in grams listed per serving for 25 cereals in that brand. It says the median fat content for Kellogg's is less than the median fat content for General Mills. That would be true because the median is going to be somewhere here for Kellogg's and somewhere in the middle for General Mills. So General Mills would be higher. So that is correct. So we don't want to mark that. The mean fat content for General Mills is larger than the mean fat content for Kellogg. That could be correct. I'm not going to sit here and calculate it out, but we'll think about that one. It says the distribution for Kellogg's fat content is left skewed, and the distribution for General Mills fat content is approximately symmetrical. This is pretty symmetrical. I mean, it's a little rough, but this one is right skewed, though. Okay, that might be something you want to have on your note card because it's opposite of what you think. Like you would think, oh, a bunch of data's on the left, it's left skewed. No, that means it's right skewed. Okay, so this is our incorrect answer. And the IQR for both distributions is approximately 1. We could calculate that out, but this is clearly the wrong answer because it's right skewed versus left skewed. Okay. This one, which of the following pie graphs represents the data? Anytime you're trying to find a pie graph, you need to know the total. So 30 plus 50 plus 100 plus 20 is 200. So we would do 30 out of 200. I would get that to be 15%. So I know freshmen are going to be 15%. So I'd look for that. I'd say, okay, freshmen are 15% here. Freshmen are 50 here. False. Freshmen are 25. False. Freshmen are 30. False. So I don't even have to do any more work. But I could do 50 divided by 200 is 25%. 100 divided by 200 is 50%. And make sure all of them are correct, which they are for question B. Okay. Remember, this is one of those ogive, ogive graphs, whatever it is, okay? It says approximate the IQR. The IQR is our Q3 minus our Q1. Q3 is at 75% of the data, and Q1 is at 25% of the data. So I would go here, and I would find 25% is approximately at 50. Again, this is an approximation. It doesn't have to be perfect, but it should be as close as you can get. Here, it's somewhere in the middle, so let's say like 68. So 68 minus 50 would be about 18. Now, if I had said this was like 49 or 48, I'd still get pretty close to 18, and that's what we're looking at. Okay, so just remember this ogive, ogive, however you say it, is always in percentiles. Okay, it's talking about the cumulative relative frequency, so it is percents. Okay, all right, moving right along. The following data represents the birth weight of 24 elephants in pounds, and thankfully that's already in a nice pretty order for you. So it says the 5-point summary: minimum is the smallest number, 99, maximum is 142. Again, if you don't know these off the top of your head, I would definitely write them down on your note card. Okay, I'm going to find the half here. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So my Q1, or my Q2, I'm sorry, is between 109 and 111. I could add those together, divide by 2, which will give me 110. And again, my Q1, I'm going to find the top half of the data. I want to include that 109, so I'm going to cross off 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. We're between 105 and 105, which is just a whopping 105. Q3, again, I am going to cross that off. I want to use a different color though. So again, I'm going to include that 111. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. It's between 117 and 119. Add those together, divide by 2 is 118. I now have my 5-point summary. Okay, you might want to write that down on your note card that this is the 5-point summary: minimum, Q1, median, which is also called a Q2, Q3, and maximum point, and how to find each of those things. Okay, find the RQR. IQR is Q3 minus Q1. Again, that might be something good to have on your note card. Outliers, you do Q3 plus the 1.5 times the IQR. And to find the lower bound, you do Q1 minus 1.5 minus IQ, or times IQR. Okay, so my Q3 for this was 118, and my Q1 was 105. So 118 minus 105, which is going to give us a whopping 13. So my Q3 was 118 plus 1.5 times 13. So 118 plus 1.5 times 13. I'm just typing that all in the calculator. Gives me 137.5. 105 minus 1.5 times 13 is 85.5. Okay. So then I look back at my data, and if there's anything bigger than 137.5, then that is an outlier. So 142 is an outlier. And if there's anything less than 85.5, there is an outlier, and there's nothing less than 85. So I'm all good. The only outlier is 142. Okay. You can make a box plot by redoing your data without our 142. Okay. So you would just pop this 142 out, find your middle, and do all of those things. And remember, just on your box plot in general, this is your min value, right? Q1, Q2, Q3, and your max value. Also remember, you need to put a number line here, label it, and your number line should be consistent. Like, you're not going to go like 3, 11, 12, 15, right? You should count by 2s, 3s, 4s, 5s, whatever that looks like, okay? All right. And you usually put a little asterisk where your outlier is, okay? So is the histogram or a box plot display the better data? Explain why you believe so. It really just depends, okay? So as long as you make a solid argument, you're good. So like a histogram would show us more the range of data in each category, whereas a box plot is going to show you where 25% of the data lies in each section. So like between the Q1, oh, I got rid of my box plot, didn't I? Between the minimum and Q1, that's 25%, 25%, 25%, 25%. So you can see kind of that spread of data differently. Whereas a histogram, you don't know exactly where 25% of the data is. You have to calculate that out a little bit better. But you do see like how many 90s there are, how many 100s, so on and so forth. So it just depends on what you're trying to look for. All right, which of the following examples would not be described as a normal curve? Remember, a normal curve looks like this. This is things like rolling a die is a really good answer, okay? So the height of an actress on Broadway, probably not going to be normally distributed. Rolling 2 dice 50 times and observing the sum of the 2 dice. How many ounces of sugar in a 20-ounce container? And the shoe size of all students in the school. Okay, I believe it is answer B because we are rolling dice. It's consistent. There's nothing that's going to change throughout there, right? How many ounces of sugar in a 20-ounce container, right? There could be a lot of variations there. And shoe sizes of all students, we're looking at 2 different types of shoe sizes, so that's not a fair representation of what's happening, okay? All right, in the rural part of the state, the distance to the local hospital, I'm sorry, I was looking for something, varies according to a normal distribution with a mean of 10.5 miles and a standard deviation of 3. The graph below shows this distribution. Sweet. According to the empirical rule, what percentage of houses are between 4.5 and 13.5 miles away? Okay. This would be definitely something I would have on my note card, which apparently my note card has disappeared on me. Oh, there it is. Okay. So having all of these data points here is super helpful. So here is 34%. If you can calculate it, that's great. But if you get a note card and you don't have to, that's 35.15. And then it mirrors itself. 0.15, because if you know these off the top of your head and they're perfect standard deviations, then you can just add these three things together, 34 plus 34 plus 13.5. And that would be 68 plus 13.5, which would be a nice 81.5. Okay. It says the amount of weight a freshman student gains when they attend a four-year college varies according to the normal distribution with a mean of 2.5 and a standard deviation of 10. If the student lost 4 pounds, so that's going to be a -4, find and interpret their z-score. So z-score is x minus the mean over standard deviation, okay? Sometimes this is written as a little mu, like a little u. Sometimes this is just an s. Whatever symbol you use, write that down on your note card. So my x is going to be -4 because we're losing 4 pounds, and this is about weight gain, minus my mean, which is 2.5, all over my 10.8. So we're going to have -4 minus 2.5 divided by 10.8, and that's going to give me -0.602. And that is talking about my standard deviations, okay? So their z-score says it's -0.602 says that they lost that many standard deviations of weight below the mean. B is their score says they are 0.062 standard deviations below the mean weight gain of 2.5 pounds. C is the 0.139, which we didn't get, and their z-score is 0.602, says they are 0.0602 standard deviations above the mean. Well, we're definitely not above the mean because we're negative, right? And we are below the mean, so we want it to be this one, but we don't want to say it's negative below the mean because that means we're actually above the mean, okay? So B is our best answer. All right, so we're administering an exam. Version A has a standard deviation of 7 and a mean of 78. Version B has a mean score of 83 and a standard deviation of 8.5. Elijah earns an 83 on version A and an 87. Which of the following statements is true? Okay, so we're looking at two different things here, so we need to make them into the same language, so we're going to put them both as a z-score. So we have 83, so again, z is x minus the mean, which was 78, all over 7, and this is 87 minus 83 over 5.8. So we're going to calculate these out separately. So 83 minus 78 divided by 7 is going to give me 0.71. And 87 minus 83 divided by 5.8 is going to give me 0.69. Okay, so Tanya did better on her final exam because her score of 87 is higher than Elijah's score of 83. We cannot say that for sure. Okay, in fact, Elijah did better because he's at 0.71. Elijah did better on the final because the standardized score of 0.75. 0.71 is higher than Tanya's score of 0.69. I would agree with that. Tanya did better on her final, and we know that's false. Elijah did better on the final because he scored in the 71st percentile. This is false information. 0.71 is the number outside the z-score. If we looked up 0.71 on our z-table and looked for that middle number, that would tell me the percentile. So I know it has to be the answer of B, okay? Because 0.71 is not a percentile. Okay. The heights of NFL players are approximately normally distributed with a mean of 71.5 and a standard deviation of 2.3. Aaron Rodgers is 6 feet 2 inches. Please remember to turn this all into inches. Otherwise, life is going to be hard for you. And I guarantee they're going to fake it. So minus 74. So I'm going to go ahead and do that. 74 minus 71.5 divided by 2.3 is going to be 1.09. I would go ahead and take a peek at that on my z-table, which I do not have a z-table pulled up here. Let's see. Okay, there we go. So I'm going to look up 1.09. 1.09 is approximately the 86th percentile. So 86th percentile is my best choice. Again, I'm looking for this number on the outside of this z-table, not the inside. The inside is when we're given a percentage. Okay, area under the normal curve responding to negative 0.3 and 1.6. I'm going to go ahead and do my z-score for both of these. So negative 0. I'm sorry, I can't do the z-score because I don't know my mean and standard deviation. I'm going to look both of these up in the table to find their percentage. So I'm going to look up negative 0.3 in my table. Negative 0.3 is 0.38